this problem deals with a quiz problem in the transformer section, parallel arrangement. And it is a scenario for which we have multiple practice problems. And the one-line question is saying that I think number 7 needs to be 700 kVA. So let me quickly walk you through this, right? It is a concept that we have discussed in a lot of depth in the on-demand course and the live training. And it relates to the transformers not being overloaded. Okay. So this scenario deals is for next 3 problems. I have a single phase 300 kVA transformer. This is the impedance. And then I have a 400 kVA transformer, and this is the impedance. Voltage, frequency, phase specifications are identical. You don't have to worry about it. Single phase paralleling of transformers is anyways a lot more easier than 3-phase. Because in the on-demand course, you guys remember also in the live training, I explained you how when it comes to the 3-phase transformers, we actually have to take into consideration the polarity, how the phase shifting happens, because if that is not taken into consideration, then you can have circulating currents, and circulating currents can destroy the transformer. Okay. So if we are going to connect them such that overloading is not an issue, and this is problem number 5. So I'm going to show you solutions for all 3, but I skipped number 6 because it's simple, right? It builds on 5 and it's just a simple arrangement. But if overloading is not an issue, and you can go above and beyond the rating of a transformer, then what would you do? Well, this is the formula that we work with, right? SL1 divided by SL2 is equal to percentage ZT2 times ST1 divided by percentage ZT2 SG2. I think there's a typo over here. I think this is T1 if I'm not mistaken. Yeah, T1. So this is a typo. So we rearrange this, and then we basically find that SL1 is equal to SL2. Okay. Now the issue with this is that what it is telling me is when I parallel these transformers and I disregard overloading, then I can have the transformer 1 loaded to the same kVA as transformer 2. So if T1 is loaded to 400 kVA, it will get overloaded, right? But the question said that don't worry about overloading. And we can have reasons why we don't have to worry about overloading. And that's basically a follow-up question that I'm going to share later on. But so in terms of transformers, fan and cooling mechanisms and whatnot, especially for shorter durations, we can write through overloading conditions. Okay. So number 5 is fairly simple. Number 6, the question is not given here. Since overloading is an issue in the given scenario, we cannot let 300 kVA transformer exceed 300 kVA. So what ends up happening is that between the 300 kVA transformer and the 400 kVA transformer, one thing is for sure, if I am to parallel these 2 transformers, then they must be equally loaded. Now the issue in 5 was that, well, the non-issue in 5 was that I could have set the 300 smaller transformer to 400 and don't worry about overloading because that's not a problem, right? In number 6, it's a problem. So what it means is that the bottleneck is the 300 kVA, correct? So if I have to make sure because of the impedances that when they're connected in parallel, they must carry equal loading, equal current, equal kVA, then I actually have to dial this one down. I have to bring this one down to the bottleneck, which is 300 kVA. So SL2 cannot be loaded more than 300 kVA if overloading is an issue. Okay, if we cannot load more than 100% of the kVA rating. And that is why in number 7, when overloading is a concern, then the S total, which the student was claiming that just add the kVA rating of your 400 and add the kVA rating of your 300 should be 700, right? Missed the point. Why? Because in this scenario, overloading is an issue and your 300 kVA becomes a bottleneck, right? And since the 2 loadings have to be equal as we determine using the formula, then we have to dial down the 400 to 300. So if low overloading is an issue, then the total kVA that we can get out of this parallel arrangement is actually 600 kVA, not 700 kVA. Make sense? So please pay attention to these details. read the question carefully. His claim is correct for number 5, but not for 6 and 7. Okay? All right. And again, please review the on-demand content, the quizzes, practice problems, and we have a lot of variety of these type of numericals with detailed explanations conceptually. And this is essentially what my response was. It's correct because if we load 300 to 400, it will get overloaded. And in the last two scenarios, overloading is a no-no. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE electrical and PE power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE electrical and PE power exam preparation programs, please visit my website, StudyForFE.com.